what is behavioral. But just understand the design pattern. When we are going for the design pattern, it is going to provide you a catalog of the design pattern, a catalog of the solutions. I said that there are 23 types of design pattern. So 23 types means the 23 types of solutions we will be having for every solutions. So this is going to software development fast. That is also one of the reason why we are using the design pattern. It will make you make the new user to develop a software as quickly as possible. Then fresher can easily develop and software. Nowadays, like new freshers are going to come, new developers are going to come into the company, and they are doing it. They have least knowledge about what the project is going on. Okay, so they will be just entering into the company, and they will be asked to go for the particular project. So since already the project is running, which is developing from the last 6 months or from the last 1 year, so what will happen? The new freshers will be having very little knowledge, a very little background knowledge of the particular project. So that's the reason fresher can also easily um, develop a software by using this design pattern, because already the design pattern is already there. With the use of those particular solutions, the new fresher can also use to it. And finally, it will decrease the complexity of the software development. So complexity, why? Because the complexity, because if we have got the same problem everywhere, so the same solution will be taken for the given problem. That's the reason it is going to decrease the complexity of the software development. So how this is called as why design pattern, and the answer to the design pattern has become the advantages. So once again, I'll repeat, there are total 6 points related to the why design pattern, which has become the advantages for the design pattern. Is first one, the design pattern solutions are reusable. Second one, establish common terminology to improve the communication. It provides a catalog for the design solution. Make the software development as quickly as possible, as fast as possible. Provide a fresher to use, and it can easily develop a particular software. And finally, it is going to decrease the complexity of the software development. So these are the advantages to the design pattern, and these are also the solutions for why design pattern we are going for it. Now coming to the model view architecture. So in the last class, when I discussed about the model view architecture, we are having a model, we are having a view, and we have having a controller. So what will have in the model view controller, that any user, let me just share my system for the model view controller. So in the session 2 only, I have discussed, the last class only, I have discussed about the model view controller. Is my system visible? I hope my system is visible.
Yes, ma'am, it is visible,
Yeah.
ma'am.
Okay, thank you. So in the last class, I have taken this, what is model view controller. I'm just taking the recap of the last classes. Okay, so the model view controller, you can check it out. We are having a model where all it is going to define the data structure. View is simply going to display the display of the given model, or you can say that it is a presentation level, and controller is going to control all the between the model and the view, how it is going to control. So if we'll talk about, I'll give you the another example. So you can check it out in this UML diagram also I have given in the last class. When the user is going to request any sort of query query, then this request will be taken with the taken into the controller side, and this controller is going to handle the request flow and then sends to the model. Model is responsible to handle all the data logic, like all the updates modification related to the data will be taken into the model side, and then from there it will interact with the database. In the model itself, the data is going to interact with the database. It will be retrieved from the database and then again sent back to the controller. So after sending back to the controller now handles this data logic and then send to the view. So this whatever the updates of the data which has been requested by the user will be given to the view. So whatever the updates are there, that will be handled by the view. So it handles the data presentation and it will have a dynamic representation. So the view is going to define the presentation of the application, and finally it will be seized at the user side, that is at the response time. At the response time, when the user requested and got back the solution, that solution will be again sent by the view to the user to see the particular data what has been requested by the user. So this is the model view architecture I have discussed in the last class. This is one more example I have given, the same diagram. The model layer is there, the browser is there, browser is in here, the user is sitting over here and requesting with the help of the browser and send request to the controller. So the controller, what it will do, controller is going to request get the data from the model layer. Now model layer is responsible to give the data from the database, retrieve the data from the database, whatever the manipulation has been done into the with the data, like updation, modification, deletion, any type of computation has to be done in the model layer itself with the data. And again, whatever the data has been there, it will be returned back to the controller layer. Now the controller layer has to give the view to the user. So how it is not going to give the direct view to the user. What it will do, it will render the dynamically render, it will dynamically send to the view layer, and view layer is responsible to give the presentation to the user. So the view layer will result sent back to the browser. Now here the user is sitting over here, can able to view the particular request that has been done by the user. So this is the way in the MVC architecture is done. Uh, this is the model view architecture. So in the last class, I have given, I have explained with the examples, every examples I have explained. I'll give you one small example, like you have already used the database. Okay, so SQL queries you have already written. So with the help of this particular diagram, I'll tell you, like the user is sitting over here in a browser and just requesting for the student details. Okay, so the browser here, the student is just asking the request to get the information of the student details. So now the request will goes to the controller layer, and if suppose the controller layer, what it will do, it will send a request to get the data from the model layer that the user has requested for the student details. Now in the model layer, what will happen, it has to interact with the database. So how we are using with the database, like the with the help of the SQL queries, we will able to request, we will able to get the data. So that is from select asterisk from student. So a student will be my table where we will be getting the data. So select asterisk from student, asterisk means it is going to select all the students which are there in the student table. So it is going to select as select the students, and whatever the data has been retrieved from the database, that will be again sent back to the controller. Now controller will get the data. That means whatever the data has been got from select asterisk from student, that data will be there in the controller layer. Now the controller layer has to view this data. So the controller layer doesn't have any like sort of facilities to view directly to the user. So what it will do, so controller layer will again send to the view layer, and view layer is going to help you, like It will give you the HTML code, or it will with the help of the HTML code also it can able to view the data, because the HTML code is basically responsible to view the particular presentation of the view layer. So now the get student presentation will be again sent back to the browser. So this is one of the example. Now here whatever we have got the data, like select asterisk from student, that means whatever the students are there into the student database, student table will be get into the controller layer. Now suppose a particular student is not there, that means it is not success, it's a failure. What it is going to do, the controller layer will be having two types of data. Okay, the controller layer will be having two types of data. One data, that will be the success data, whichever the students are available in the student student table, and the other one is the view error, that means a particular student which is not available. So based on the query in the model layer, it is going to return back the solution, return back the data to the controller layer, and the same controller layer is going to display to the browser. So this is the MVC architecture. So I'll just stop sharing this. So this is called as MVC architecture. Now the catalog of design pattern. So I have discussed about the MVC architecture. Now the question goes to what are the different types of design pattern. So the basically the design pattern is divided into three different parts, that is the creational, structural, and behavior. So what is creational, what is structure, and what is behavior? So creational, with the word itself, it is that means that we are going to create. We are going to create a particular design pattern. So creation pattern deals with the complexity which is associated with the creating objects. So the data which has been created with the objects will be deal with the creational pattern. So object oriented programming is full of objects. That's the reason creational pattern will take the objects, create the object. With the help of the objects, it will create and then display into it. So there are varied kind of objects that we create with the varied range of problems. So based on the problems, the objects will be created. Based on the class, the objects will be created. Next, coming to the structural design pattern. So structural design patterns deal with the composition of the classes. So structure means what is the composition of the particular class, what class it contains. Okay, what data types it is going to contain, what does the class contain, what relationship does it have with the another class, with the same class also, and with the another class also. So the structural design pattern is going to define the structural composition of the classes. Okay, so it can have a different data types of the particular attribute, different data types of the attributes in the class. It may have the relationship between the two different classes. It may have the inheritance pattern also from one class to the another class, or you can say that the derived class can be taken from the base class. So the does it contain the object of the another class can also be checked into the structure design pattern. So all these types of the design pattern are basically grouped into the structural design pattern. So the next one is the last category of the catalog of the design pattern is the behavioral design pattern. So behavioral means it is going to define the behavior of the objects. Okay. So the behavioral pattern that is mostly it is going to focus on the behavior of the objects. So that is basically how the interaction between the objects are going on. What is the behavior of the object when it is inherited from the one class? Okay, what is the behavior of objects when it is connected to the friend class? So how it is going to interact? So that is called as behavior of the objects. So how does an object communicate with the another object is basically seen in the behavioral design pattern. So in the last class, I have also discussed what are creational design pattern. So there are in total six design pattern taken into the creational pattern. That is the prototype, clone, builder, singleton, factory method, factory method, and object pool pattern. So these are the different types of design pattern which is taken into the creation. Don't worry, the ultimately when we will be speaking about these different types of pattern, you will be able to by heart by itself. Okay, so don't try to by heart, oh ma'am is saying this new words, I have to note it down. Be relaxed, just listen to the class, because slowly when we go for the CO2 and CO3, it is divided into all these three types of design pattern. That is the creational, structural, and behavior. Just adapt these new words. What are these words are? I have listened these words in this class. So what are this prototype pattern? What are this prototype is basically just as a clone. So I'll give you the example like prototype, like we are using a banking system. So in a ATM machine, we are using the ATM card. So ATM card will act as a prototype. Why? Because the ATM card contains all the information of the bank account. Okay, so all the information means what is the account number of the holder which is having the particular ATM card. What is the 16 digit of the ATM card which is holding by the particular account holder, what is the expiry date, or what is the expiry date, what is the CVV number of the ATM card which the account holder is having. Also, what is the balance of the account, balance in the account of the given account holder account. Okay, so if any transaction will be done, so how many balance is being left, so everything will be taken into one card, that is called as prototype. That is called as prototype. I'll give you with the examples, and we will go through the examples. We'll be having soon, we'll be having the different types. Based on that types, we are having the examples, and based on that examples only, we have to use this design pattern. Particular types of design pattern is going to reflect which type of problem it has to be. So creational contains prototype, creational contains the builder design pattern, creational contains the singleton. If it is single type of problem is there, then single solution should be there for the given problem. So singleton pattern is also into the form of creational. We have factory method. So factory method is also a part of the creational design pattern. And finally the abstract factory method, which is also the part of creational design pattern. Now coming to the structure. So in the structure we have again a total 7 types of design pattern. That is proxy, decorator, facade, adapter, flyweight, bridge, composite. So these are the total 7 types of structural design pattern which is going to define about the structure of an object. So again, I'll repeat, that is the proxy design pattern, the decorator design pattern, the facade design pattern, the adapter design pattern, the flyweight design pattern, bridge design pattern, and as well as the composite design pattern are the parts of the structure design pattern. Now coming to the behavioral design pattern. So behavioral design pattern is basically total 10 types of behavior design pattern which is going to which is going to tell you about the behavior of an object. So the behavior of the object can be checked with the help of chain of responsibility, iterator, state, strategy, observer, visitor, template method, command, memento, mediator, and as well as interpreter. So in total, we are having 10 types of behavioral pattern. So once again, I will repeat the types of the behavioral pattern which is going to define about the behavior of the object that has to be used in a particular class or that has been used in a particular application. So the consists of the behavior of an object consists of different types such as chain of responsibility, iterator, state, strategy, observer, visitor, template method, command, memento, finally the mediator. And sometimes the interpreter is also there in the behavioral types of behavioral design pattern. So these are the things which I have discussed in the last class. So now today I'll be going towards the next one is how to use the pattern, how what is the pattern of the design pattern, how to form this, what are the basic elements of the design pattern, and how these basic elements are used in the design pattern. Then, with the help of this basic elements, what should be the template of the design pattern? And after that, after the templates of the design pattern, I'll tell you how to use this design pattern, what are why to use this design pattern. Okay, so going for the any doubt till here, till the last class, put it into the chat box. I'm there to check it out. Any doubt regarding this, the last class, which I have discussed, what is design pattern, how the existence of the design pattern came, what should be, why the design pattern, the solution of the design pattern become the advantages for the design pattern. So, what is the MVC architecture, and finally the catalog of the design pattern. Any doubt? Any doubt? I'm there in the chat box. So that I'll move forward to the next topic, that is the basic elements of the design pattern. Yeah, I'll wait for the 1 minute. No doubt, ma'am. So Saran has given no doubt. Okay, please proceed. Any more students who can put up? Okay, Kiran has also said that no doubt. Fine, fine. Harsha has kept. Okay, fine. If any doubt is there, put up into the chat box. The faculty are there to help you out. Okay, so I'm just proceeding for the next one, that is the basic elements of the design pattern. So the basic elements of the design pattern consists of four parts. The four basic elements are there for the design pattern. That is the pattern name, the problem, the solution, and finally the consequences of the design pattern. So pattern name. So the name itself is going to define the name of the pattern. So we'll be very much clear about whatever the name we are giving. The name itself is going to define which type of pattern it is. Okay, which type of pattern it should be. Next one is the problem. So problem means it is going to describe when to apply the pattern. So problem, we have to identify the problem, we have to check the problem, what type of problem it is, and it is going to describe like what pattern should be applied for the given problem. Since we are having a solution, since we are having a problem, we will also have the solution. So based on the problem, we'll be having the solution. So element that solves the problem is called as the solution. So that is here the fourth one is the solution, and finally the consequences. Look, like some of the solutions we are given for the given problem is going to give you some result. So how these results are going to apply after like any problem, if any solution is there, and this solution is we are going to apply into the given problem. So what will be the consequences? what should be the consequences. It should be like profitable, or it should be like loss enough, or we can easily able to get the result. So what are the consequences when we are applying the particular solution to the given problem? So we'll go through it one by one. Like, what is pattern name? So pattern name is basically, it is going to handle, I said that it should be the name of the pattern. So pattern name is a handle, we can is a name that is going to be handled where we describe a design problem. Okay, so name of the problem, name of the pattern is going to define about the design problem. So it's solution and consequences in a word or two. That naming of the pattern immediately increases the design of the vocabulary. So if you'll give the name, like for example, I'm giving the name of our university, that is KL University. Okay, so the KL University, the vocabulary is here. The KL is itself a university. So university means it will be having a number of departments. So based on the naming of the pattern, it will define everything. Okay, it will define everything. So let us design at a higher level of the abstraction. So the pattern name is generally going to give the higher level of the abstraction. Okay, having a vocabulary for pattern, let us talk about them. It is going to define the vocabulary of the given problem. Like I said, KL University. So the KL University has the number of departments. Each department has the number of courses. Okay, each department has the number of courses. So that's the reason the vocabulary for the pattern is just defined with the help of the pattern name. So it makes it easier to think about design and to communicate them and their trade-offs to other. That's the reason the pattern name should is very important, and based on the name of the pattern, it should define the particular problem. It will define the particular problem based on the name itself. Okay, like I suppose I say student details. So student details, that means the particular name of the student details consists of the name of the students, the ID of the students, the details of the students. Okay, like who are the what is the further name of the students, in which course he or she belongs. Okay, what are the number of subjects has been there allotted to the particular students. Everything will come under with the name of that particular pattern. Now coming to the next one, that is called as the problem. So pattern elements has the problem. The second one is the basic element of the design pattern is the problem. So what the problem is going to be do? So the problem describes when to apply this particular pattern. Since we are having number of patterns, okay, we are having number of patterns. Now, particular pattern belongs to which type, which problem it has to be. So we have to see that first we have to identify the problem. Now, based on the identification of the problem, we have to see that in which context the problem has been given. That also we have to check it out. So it explains the problem and in which context it has been identified. So that is the main thing, we have to check it out in the problem. So it might describe specific design problem such as how to present algorithm as objects. Okay, so a given problem which we are having, that a specific design problem is there, such as to represent the algorithm as the object. Like we have taken, you take the any algorithm, you take any algorithm you are taking. Now how this algorithm is going to be used as an object. So since when we are writing the program, when the developer is writing a program, programmer is writing the program for any project, it won't write every algorithm into the one code. Okay, so what they will do, they will write the algorithm. For example, we'll take the example for the calculator. Okay, so if we are building a calculator, so calculator has how many operations? Addition, subtraction, multiplication, division, and modulus. Okay, so what we'll do, we'll write the code, we'll write the algorithm for the addition, we'll write the algorithm for the subtraction, we'll write the algorithm for the multiplication, and goes on. So finally what we'll do, we'll club this algorithm into one calculator form with the help of the object. So, in which context it has been written, that we have to understand with the given problem. It might describe the class or the object structures. So, the what type of class it is, what type of structure of the given class it will be, that has to be symptomatic of an inflexible design. And sometimes the problem will include a list of conditions that must be met before it makes to sense to apply the pattern. So that is the thing, that in the problem we will be simply identifying the problem of the given pattern, and we will check that in which context a particular problem has been identified. Since the problem is identified properly, problem has been understood with what context the problem has been identified, then we will go for the solution. Then we will go for the solution. So the solution is generally related to the given problem. Whatever the problem has been identified, based on that particular problem, the solution has to be identified. So the solution is going to describe what? It is going to describe the elements that make up the design, the relationships, the responsibilities, and the collaborations. So the solution which is going to describe about the elements is based on the relationship, based on the responsibilities, as well as the collaboration of the given design pattern. So the solution is going to give you, or it will solve the given problem. So solution does not describe a particular concrete design. So it is not going to define the what is the type of the design. It is just simply implement that particular solution to the given problem, because a pattern is just like a template that can be applied in many different situations. So after the solution, I'll tell you how the template is going to be work. What is the template? How the template should be for the given problem. Okay, so the solution, it doesn't describe a particular concrete design. It is basically an implementation, because the pattern is just like a template that can be applied for the given different situation. Since instead the pattern provides an abstract description of the design problem, so it is how a general arrangement of the elements, classes, and objects in our case is going to be solved. So generally, when we go for the pattern, when we go for the solution of the given problem, so it is going to define the abstract description of the given design problem, and then it will give you the solution for the given problem. So this is called a solution. So solution is basically going a solution. We have named the design pattern. After naming, we have gone through the identification of the problem. After identified in which context the problem has been taken, based on that we have taken the solutions. After finding the solutions, we will go for the consequences. So consequences is basically going to give you the result. Okay, result of those solution that is going to be applied for the given design pattern. Okay, for those solutions which has been identified for the given problem. So when the solution will be applied for the given problem, so what is the impact? We can say that what should be the impact. Okay, so consequences are basically, it is a result or the trait of for applying the particular pattern. So the consequences for software often concern space and time trade-off. So sometimes it may concern